let's say minimize over all alpha beta. So what do I get? I get, let's say, okay, so what I can do is I can call this vector as V, okay? This vector as V. Instead of minimizing over all alpha beta, I can minimize over all V belonging to span of V1, V2, right? That's what I have done. Alpha beta, if I vary, I'll get different vectors in the span of V1, V2, right? It's equivalent. So if I find such a vector, so this argmin will give me the vector V that will minimize, right? So this is nothing but the projection of V2. I think this is V3, right? Sorry, I'll write this is V3. Projection of V3 onto span of V1, V2. Okay, so keep this in mind, because if you look at many of the machine learning problems, what happens is you find the neural network weights, and you want the neural network weights, the norm squared should be small, right? So you have to project onto some space. So exactly this is the problem that you will solve. Keep this in mind. Is that fine? How many of you know regularizers in data or neural network? Anyone used have programmed or programmed a neural network, or trained a neural network in Python? Model.fit. How many of you have studied model.fit? No? Yes or no? Nobody? Okay, one guy. Okay, good. You? So you have used. So what are the parameters there that you give? Learning rate. We will see what that is later in the class. Yes. Optimizer. Good. We will also see what that is. Loss. For example, squared error. If you look at this squared error is a loss. There is many losses. Fine. Model parameter. Essentially, it says how the neural network architecture is. Okay. Data. Okay, you haven't used regularizer. Okay, so you can add regularizer to as a part of the loss function, or you can also specify as a separate regularizer, right? So essentially, it says the norm of the neural network weight should be small, right? We'll add that as lambda times norm of W, right? Why? Because I don't want the neural network to. I should restrict my choices of neural networks. How do I restrict? I'll make sure that the norm of that is less than or equal to something. So basically, it should be within some space, right? So I cannot choose any neural network I want. That's called regularizer, right? So the moment I add that, or if that is a set, I have to project onto that. So projection is exactly this problem. Okay, so we will revisit this later. Okay, now you know Gram-Schmidt's, right? So we can again refer to the notes or the textbook that, or the notes that I have written. So you can go through the chapter on, or whatever the part of the notebook where I have described the Gram-Schmidt's in detail. Okay, for a general vector space V. But I think this is clear, right? Whatever I have done, is that fine? In fact, I can do the same thing for many other vector spaces also, function space, whatever, right? So same technique will work. So what is the solution of such problem in functional spaces? Same thing, right? It's quite interesting. Do you agree? If I want to project onto something, the solution will be very, very close to what we have. It's just that the language is different. Instead of saying U transpose V, you'll say inner product of something with something. That's all, right? It's quite general. Okay, so we will also solve the same problem using, for example, using, let's say, the optimization techniques. Okay. Okay, any questions? So maybe I'll pause for a minute and then we will move on. Any questions? No? No questions? Those who are online? Okay. Okay, so if there are no questions, let's move on. So let's look at the use of this, right? So let's see what happens if I have, let's say, a simple 2 cross 2 matrix.